So in this example, we're basically reverse engineering what we've done before. Now I've told you what sine of theta is. Sine of theta is 0.5. I've also told you specifically that we're dealing with all thetas, all angles, between 0 and 360 degrees. That piece is unimportant right now, but it does become important in a little bit. To find theta, we need to take the sine, we need to move it to the other side. In algebra, we'd call that dividing by. It's not exactly the same in trigonometry. So we need to actually move it to the other side. What happens? We get theta equals, that is read as sine inverse of 0.5. This is easy enough to type in the calculator. First of all, make sure the calculator is in degree mode. And to get to the sine inverse function, we hit second and sine of 0.5. And it tells us straight away that theta is 30 degrees. Now, with every trig equation, there's always actually two possible values of theta that would give us a sine of 0.5. The calculator tells us one of them easily, but not the other one. The other one we actually have to go and find by hand. To do that, we need to draw out what 30 degrees looks like, which would be roughly here. We also need to rely on cast. So C-A-S-T. Now this second angle that gives us a sine value of 0.5 will be a 30-degree angle into one of those other three quadrants. The question is which quadrant? So we need to look back at the original equation. And what we had is we had sine theta equaling a positive number. So we then need to find the other quadrant in which sine is positive. That one's labeled with an S. So to find that angle, we'll draw an angle 30 degrees into that quadrant. But that's not the actual angle we want. The actual angle we want is always measured from standard position, so it would be actually here. So then our second angle, if we call that theta 2, the way we'd calculate that, well, we know if we go all the way to the x-axis, we'd have 180 degrees, but we were 30 degrees short of that, so our theta 2 is 150 degrees. So yes, we have two answers when solving a trig equation. We will always have two answers when solving a trig equation. Jumping ahead to a different example, again, we're dealing with all angles between 0 and 360 degrees, so we will have to find a second answer. We have cos theta equals negative root 3 over 2. Need to move the cosine to the other side, so theta equaling cosine inverse of negative root 3 over 2. We can jump over to the calculator. So second function cosine, negative root 3. And we need to close the bracket on this, otherwise the calculator will think that the whole fraction is inside a root, not just the 3. So negative root 3 over 2 tells us that our theta is 150 degrees. Drawing that out on xy axis, 150 degrees is well into quadrant 2, right about here. Going back to cast, and the original equation up here, we had cosine equaling a negative number. So we then need to find the other quadrant in which cosine is negative. That would be quadrant 3, labeled with a T. Now we can't exactly draw a 150-degree angle into that quadrant. We can draw something that is less than 90. So at this point we need to look and we need to make a reference angle. So how far is that 150-degree angle from the x-axis? Well, it happens to be 30 degrees. That's how far we're going to draw into quadrant 3. So that is 30 degrees. The angle that we're looking for the final answer is always from standard position, so that would be like this. So then our theta 2, to get that, well, we had to go the whole 180 degrees to the x-axis, plus another 30 would give us a final answer of 210. So 150 degrees and 210 degrees.